So to get twisted pair cabling to work with Ethernet, we have to wire the cables very precisely. Now, if you remember looking here, these wires are all color coded. They're orange, white, and orange, brown, white, and brown, green, white, and green, and blue, white, and blue. So what we do then is we use this cable end, and this cable end is called an RJ45. It's what we see connected to the ends of the cables here. And we can buy them separately. We do not have to buy pre-constructed cables. As a network engineer, you can actually learn how to build these. I've done so many of these, tens of thousands of putting cable ends on. I still have calluses on my fingers to do it. And now with resources like monoprice.com out there, you can get cabling for 10 cents a piece. It's really not even worth wasting your time trying to put the end on anymore. There's machines that can do it. So for the wiring standards, though, we still do have a standard, and the EIA TIA came up with a standard. The one that we use for making patch cables is 568B. And the way 568B works is it assigns the orange-white wire to pin 1 over here on the right-hand side of my drawing. Then pin 2 will get orange, pin 3 will get white-green, 4 will get blue, 5 will get white-blue, 6 will get green, 7 will get white-brown, and 8 will get brown. All right, great. Well, how do they come up with this? Well, if we take a look at the RJ45 connector here with wires in it, the way this is set up is we actually only use 4 wires to use Ethernet. This is for the most part. There are some applications of gigabit Ethernet which use all 8 wires, and there are some applications where we use something called power over Ethernet. And it's where we actually use the Ethernet cable to supply power to our devices. And this is a really cool technology. We use it to supply power to wireless access points and voice over IP telephones, among other things. And sometimes those will use the unused pins of Ethernet as well, but traditionally we're sticking to these 4 pins and we don't need much else than that. So pins 1 and 2, the orange and orange-white pair, are the transmit wires. So we have transmit positive on pin 1, which is orange-white, and transmit negative, which is on pin 2, which is straight up orange. Do the electrons going through the wires care what color they are? No, but the humans do, and we care about the colors because the colors are associated with the twist, and the twist is important so we can prevent crosstalk. If we don't get the colors lined up right, and the pairs lined up right, more importantly, we end up creating too much crosstalk, and you can actually degrade the performance of your cable by 80 or 90%. That means if you have a 100 megabit connection, the maximum you can get out of it is maybe 10 megabits. That's unacceptable for something as simply as a poorly constructed cable. So pins 1 and 2 are our transmit, and then pins 3 and 6 are the receive wires. So receive positive and receive negative. Receive positive is green-white, and receive negative is green. The other 2 pair of wire fall in the middle of our receive wires and on the far end here. And we can use those, like I said, for other applications if we need them. But for the most part, Ethernet is using those 4 wires.